Good morning, ladies and gents. Well, at least it's morning when I am recording this. I don't know if it's morning when you're watching it. We are going to continue talking about parabolas and how they change or how they can look different from one parabola to the next. In your workbook, we are going to start on page 266. I'll do a quick little review first of what we've talked about thus far, and then we'll continue with a little bit of new stuff. So page 266 in your workbook. I would highly suggest that you log on to Agile Mind and work along with me today. There's some slides and some opportunities within Agile Mind that could be really helpful as we work through today's notes. So if you are on Agile Mind, you're going to go to My Courses right here on the top. Click on that. Then you are going to scroll down underneath Course Contents until you find Unit 8. Underneath Unit 8, hit the down arrow next to Topic 22. And then once that opens up, the down arrow next to lessons, and you're going to select lesson 4. So lesson 4 underneath topic 22. Lesson 4 underneath topic 22. Once you are there, you can hover over the 3 dots, and we are going to start on page 17. We're going to start on page 17 as a little bit of review. And again, this page 17 goes with page 266 in your workbook. I'm not going to fill in page 266 with you because what's on page 266 is exactly what you're seeing on my computer screen right now. However, I will upload along with all these notes that you're seeing after we do these notes, I'll upload a picture of my workbook with everything completed in it so you can verify what you've written in yours. So parabolas. We know that a quadratic equation is an equation that has the highest exponent of 2. That is our only requirement. We've talked about identifying quadratics based on the equation, and looking for that exponent of 2 makes it really easy. We've talked about identifying quadratics based on a table, looking for that common second difference in the y's. Then we started talking about the shape of the graph of a quadratic. A quadratic's graph is a U-shape. But telling anyone that you learned about U's today is very kindergarten or even preschool, probably. So we have a fancier name for that U shape. We call it a parabola. Last time we met, or in the last lesson that you watched, we talked about how that A value, that number right up here in the right-hand corner, that number in front of the x squared, how that adjusts the parabola. That does a couple things. That A value, depending on it, can keep the parabola opening upward. It can flip and make the parabola, open down. And that A value can actually make my parabola wider. It can make it narrower or skinnier. So let's start about the opening up versus the opening down. We know that when that A value is positive, when it's positive, I'll look at my options, the parabola is going to open upward. If I just have the equation x squared, by default, it's positive, and that parabola is going to go open upward. So on the flip side, no pun intended, on the flip side, if I go from a positive to a negative, I'm going to literally flip my parabola over, making it open downward. Okay, then we talked about throwing numbers in front of x squared, actually A having a value. So you might be thinking over here, what are these bars around the A? We've seen those before. That's absolute value. Remember, absolute value really just gives you a positive number. So the absolute value, let's say, of -2 would be +2. Absolute value is really saying disregard any negative. A negative does not have any effect on does the parabola get wider or narrower. The negative only keeps it opening upward or opening downward, depending on if you have that negative or not. So that absolute value, again, is saying disregard the negative, only worry about the positive. What is that number, if it was positive, in front of the x squared? What is it doing? So if you remember my little hint about remembering this, about how much you work out. If you work out twice as much as you do now, or 3 times as much, or 10 times as much, theoretically, you should be getting skinnier. And if you work out half as much, 0.25, a third as much as you do now, theoretically, you should be getting fatter, you should be getting wider. So using that to help you, as the absolute value of A increases, so 2, 3, 5, 7, that is when you get skinnier. Now you'll notice skinnier is not an option here. There's some other verbiage that mathematicians like to use. Think about taking the parabola and holding the tips of the parabola. If you were to stretch them up, notice what just happened to my arms. Here's my parabola. If somebody else took a hold of my arms and stretched them up, I would get skinnier. So I will write this in my book as that A value increases, 2, 3, 4, 5 again. That is how you get skinnier or narrower, which is also called a vertical stretch. And on the opposite side, if that A value decreases, so that's your 1/2, your 0.3, your 0.25, your 0.8, anything between 0 and 1, that is when your parabola gets wider, which is also called a vertical compression. Also called a vertical compression. So that's a little bit of review of what we talked about previously. I can hit submit here if we wanted to. The only reason it says partially correct is because we haven't talked about these bottom three, but notice nothing else that we had up here changed. So make sure that you have that on page 266. Sorry, I feel like I'm going to sneeze here. Make sure you fill that in on page 266. And then we are actually going to flip to page 262. And while we flip around to page 262, I'm actually going to flip my computer around here and I'm going to work through page 262 with you. So here we go. Now, I do not know why. No, actually, I do know why. My daughter was playing with her Osmo reflector and now it's really, it's all smudged on the glass. So hopefully that helps. Yes, there we go. We're going to start on page 262, and we are going to graph a couple parabolas. Now, since you have Agile Mind open on your computer, it would be really helpful if you hit that calculator up in the upper right-hand corner, selected graphing calculator, and you can graph right in there, then translate those graphs right onto this graph paper here. Again, I'm going to let you utilize that calculator in the upper right corner. If you have your own graphing calculator home, you can also use that. If you followed the directions the last time we virtually met and you installed the graphing calculator on your computer, you could also use that one. If you haven't, if you're like, what are you talking about, Mrs. P, make sure you go back to the April 9th module and click on the link that talks about installing the calculator on your computer. That calculator functions exactly like the ones that we are used to using in class. So if you'd rather use that, you totally can. But anyway, page 262, we're going to start with number 5. We're going to go a lot out of order. We have, again, talked about parabolas. There's my most basic parabola. I want you to go ahead, if you need the calculator to help you, sketch that on there. We're going to have a vertex right at 0, 0. I know that we have the points 1, 1, negative 1, 1, because again, we are symmetric, and 2, 4, and negative 4, negative 2, positive 4. And again, if you are graphing these on your calculator, if you're wondering, Mrs. P, how do you know this? Those points, you can see them on the graph in your computer. Okay, so there is x squared. Again, we've talked about putting numbers right in front of x squared, but what if we put numbers after x squared? What if we add something? What if we subtract something? So what if we were to graph something like y equals, and I'm going to use this one right up here, x squared plus 6. I want you to go ahead and throw that into your Desmos calculator or whatever calculator you're using, and I want you to watch what happens. I want you to take that graph and I want you to translate it right onto this graph paper right here. What you should notice, feel free to pause the video if you need to get that done. What you should notice is we call this actually our axis of symmetry. Our line of symmetry does not change. The middle of my parabola, think of that axis of symmetry or line of symmetry as the middle of your parabola, cuts your parabola in half. We've talked about symmetry before. That axis of symmetry doesn't change. My vertex is finally going to move. As we have put numbers in front of x squared, a values in front, my vertex stayed right here at 0, 0, but by putting a number after the x squared, adding that 6, my vertex has shifted. You should notice that the vertex actually shifted up to the point 0, 6. That vertex shifted up to the point 0, 6. So I'm going to make a note, shifted vertex to the point 0, 6. So I'm going to pick just another one. Let's go with y equals x squared minus 2. And if you need to pause the video, please pause the video, throw this into your calculator, see what happens. And you should notice that, again, that axis of symmetry did not change as compared to x squared. That axis of symmetry did not change as compared to x squared plus 6, but my vertex has shifted, and this time it shifted down to negative 2. This time my vertex shifted down to negative 2. I guess I could label the rest of these x squared plus 6. And this one where it shifted down is x squared minus 2. It shifted the vertex to 0, negative 2. So it seems like when we add or subtract numbers after the x squared, when we add or subtract numbers after the x squared, our parabola either shifts up, the vertex does, or shifts down. We decide that our parabola is shifting up or down based on the location of the vertex. So with x squared plus 6, our vertex shifted up to 0, 6. And with x squared minus 2, our vertex shifted down to 0, negative 2. 0, negative 2. So we're going to continue to play with what happens when we add or subtract numbers on the bottom. We are going to move down to number 7, but I'm going to let you fill in number 7 as I work on your Agile Mind screen. Again, if you have Agile Mind open on your computer, that will help tremendously. And on Agile Mind this time, we are going to, if you hover over those 3 dots, we are going to go to page 8. We are going to go backwards to page 8. Hopefully this opens here. Okay, so the nice part of this page, it actually is going to, these sliders on the right-hand side, you'll notice, are going to allow us to change this adding value to the backside. It's going to allow us to change that just by sliding this little triangle right here. Notice how that's moving. Now notice how not that you can see, I'm pointing at the screen, notice how that dotted line does not change at all. That dotted line is just the parabola x squared with 0 added to the end. Now adding 0 really means I've added nothing. So that is just my parent parabola, just the basic x squared. So again, as we work on this screen, we're going to fill in 7a. And 7a has this question right up here. What happens to the parabola when the k value, that value that is at the, that we're adding or subtracting at the end, when it's increased? Okay, so I'm going to reset this to 0. What happens to that k value or what happens to your parabola as that k value increases? Well, notice I put that k value increase to 1. What happened to my parabola? Look at where the vertex is. It is at 0, 1. I'm going to shift that k, increase it to about 3, if I get that there. And when that k value is at 3, notice my parabola, its vertex is at 0, 3. So it seems like as my k value increases, the parabola moves up the y-axis, and the vertex is at the point 0k. This is exactly what you should be writing in 7a in your book. The parabola moves up or shifts up. Parabola shifts up. And you can say it shifts up the y-axis. And the vertex is going to be at, if you added 3, it's at 0, 3. If you added 5, it would be at 0, 5. So we can say the vertex is at 0k. Now I'm going to hit 2 down here, and this will move us to 7b if you are on page 262. What happens to the parabola when the k value becomes negative? Now, in the example where we drew right in our books, we thought about it as subtracting. We know that a subtraction sign is a negative sign for all intents and purposes. So what happens when I subtract a value or I have a negative? Well, if I go down to negative 2, now notice it does say plus negative, that's almost negative 2, plus a negative. A positive and a negative is the exact same thing as subtracting. So I shifted down to about 2. Notice what negative 2. Notice where my vertex is, 0, negative 2. If I pull that slider down to negative 5, I'm going to go all the way to the bottom. My vertex is at the point 0, 0, negative 5. So again, 7b on page 262, what happens to the parabola when the k value is less than 0. So in other words, when it's negative, well, we notice that the parabola, and I can hit this button to check it, we notice that the parabola shifts down the y-axis. Sorry, I'll make that go away. It shifts down the y-axis. Or we could say that the vertex, now actually this is the exact same summary as 7a, the vertex is at that point 0k still. So if my k value becomes a negative 5, my vertex is at 0, negative 5. If my parabola is at 0, shifts down to, I subtract 2. Remember, adding a negative is the same thing as subtracting. Then my vertex is at 0, negative 2. I'm going to hit the 3 right here, and we're going to move on to 7c. We're going to move on to 7c. So how is the graph of x squared plus 1 similar to the graph of x squared minus 1? And how are those graphs different? So we're going to do a little comparing and contrasting. Now, before I even adjust any graphs here, adding 1, subtracting 1. We know that that does not change the line of symmetry down my parabola. It's not going to change where that middle, if you will, of the parabola is. But adding 1 should shift my parabola up, and subtracting 1 should shift my parabola down. So I'm going to first go, oh, there's x squared plus 1. There's x squared plus 1. Middle of my parabola has not changed at all, that line of symmetry again, but my vertex shifted up. And x squared minus 1, as I predicted, it's about minus 1. It's hard to get that slider in the right spot, shifts the vertex of my parabola down. So how are x squared plus 1 and x squared minus 1 similar? How are they different? This would, again, 7c on page 262. They're still parabolas. They're still U-shape. The axis of symmetry, or the line of symmetry, the middle of the parabola, however you want to describe it, axis of symmetry is still the y-axis. However, x squared plus 1 is going to shift up 1, and x squared minus 1 is going to shift down 1. So take a second, pause this if you need to, and I want you to copy this into 7c or put some sort of summary into 7c. And then we are going to continue on. I'm writing in my book right now. If you're wondering, what is she looking at? I am writing in my book. I'm doing this down, along with you. So x squared plus 1 shifts up 1. So vertex is at 0, 1. X squared minus 1 shifts down. Vertex is at 0, negative 1. Okay. So we talked about now what adding or subtracting a number at the end, that's referred to as a k-value, what that does for us. We are going to move on to page 9 if you are following along on Agile Mind. So I'm just going to hit the arrow. Come on, here we go. So page 263 in your book, says sketch a graph of x squared minus 2. So go ahead and pause the video, and I want you to sketch in a graph of x squared minus 2. And once you have that in your book, you will know, you should be able to predict before you even put this into any sort of graphing calculator, x squared minus 2 should shift the vertex of the parabola down 2 units. It should shift the vertex of the parabola down 2 units. Okay, let's see if I can get that to match right here. I'm going to shift it down. Oh, nope, I don't want it to get wider or skinnier. Shifting on the computer is really tough. Wow. Let's try resetting the graph. This is not fun trying to do this on the computer, but I'd really like it to match to make, there we go, down 2. Here we go. So answering the questions on page 263, number 8, we sketch the graph. What are the coordinates of the vertex? So if I looked at the vertex, I have gone 0 side to side. So I'm going to have an x coordinate of 0, but I have shifted down 2. So I have a vertex, we have vertex coordinates of 0, negative 2, and this is A on page 263. Now, some other questions. Does the function have a maximum value or a minimum value, and what is that value? So now, thinking about the word maximum, it's the highest value. And that's really hard for us to describe in this particular parabola, because these sides of my U continue to go up. So the maximum value could be 10, 20, 30. They go on indefinitely. So we can't say that it has a specific maximum value. But a minimum means a lowest value. And in the case of this parabola, if I look down, do we go down to negative 4? No. Do we go down to negative 3? No. The lowest we go, this parabola does indeed have a minimum. The lowest that this parabola goes is negative 2. So its minimum is actually right there at the vertex, a minimum of negative 2. A minimum of negative 2. I'll submit that answer. There we go. A minimum at y equals negative 2. Okay, so let's do a couple more graphs. I am going to flip my computer around so that way you can work with me and you can see what I am working on. I'm just checking what it is I'm supposed to be covering today. So let's flip this around. Here we go. We are going to move to page 265. Page 265, we're going to do numbers 9 and 10 on page 265. Now you'll notice 265 throws in both an A value, a number in front right here, that's my A, and it throws in a K value, that adding and subtracting that we've just discovered, or that we've just explored, that is called a K value. So what happens when we put these together? Again, you are welcome to use your graphing calculator. You are welcome to use the calculator built in to Desmos to help you with these. But what does that K value, that A and K value do? Well, let's see. Adding 2, we know that this K value of adding 2 is going to shift my vertex up 2. My vertex up 2, or vertex at 0 over 2 up. And again, if you graph this in any calculator, you'll notice, oh, yep, that's true. What is that A value going to do? Well, if I work out 3 times as much, theoretically, I should get skinnier. So my parabola is going to be skinnier than just a normal x squared graph, and it's going to shift up 2. So I'm going to go ahead and sketch something that is skinnier than normal, and the vertex is shifted up 2 in my book. Similarly, number 10, now notice number 10 actually has the same numbers as number 9, but in different places. Does that mean we're going to get the same graph? The answer is no. That plus 3 means we are going to shift up 3, or my vertex this time is going to be at 0, positive 3. So 0 over 3 up. And that 2 does mean I'm going to be skinnier than a normal x squared graph. Does that mean I'm going to be as skinny as number 9? No, because if I work out 3 times as much, I'm going to be skinnier than a person who works out 2 times as much. 2 is still going to make you skinnier than just old x squared, but not quite as skinny as someone who works out 3 times as much. Okay, and shifting over one more page, 266, and again, if you're an Agile Mind, you can go back to page 17 in those slides. Let's finish this up talking about what happens if we've talked about or reviewed the A's, but now what happens if we have a K at the end? What if we put a number after the x squared? So as that K value increases, add 2, 3, 4, 5, we know the vertex shifts up. And as that K value decreases, we start subtracting, we know that that vertex shifts down. The vertex shifts down. And we know that adding or subtracting a number at the end really dictates where the vertex is going to be. That vertex is still going to stay on the y-axis, but that y value is going to either increase to whatever k is or decrease to whatever k is. So the vertex will be at the points 0, k. So at this point, again, we've talked about what does a number in front of x squared do to our parabola. And now we've added on what does a number adding or subtracting after the x squared do to our parabola. So I'm going to have you practice with that a little bit. Please use your calculator to help you. You can play with equations in there very, very easily. Make sure you use your book as reference as well. And as it says in Canvas, you are going to complete the next page, page 267. You're going to complete page 267, complete 1, 2, and 3, and you're going to submit those to me on Canvas. Talk to you later.